That's the ideal. I'm just curious. I can collect them now, or we could put them in a pile if you'd like. All right. All right. Well, they're all about the right length. That's good. Nobody wrote a 20-page response. Thanks. Great. Okay, is there anybody who has not turned in a homework, who plans to do it later for whatever reason they couldn't? That's wonderful. Homework. There's no handout, but I am looking for homework, if you have your homework. And it's really nice. There's no handout, but we are looking for homework. If you have your homework done, good. Okay. Great, thank you. So did anybody have any problems with the homework? Was it fun? Was it difficult? Was it harder than you thought it was going to be when you got down to it? Anybody have any good answers to how to define the difference between the prior art leaf rake and the two-handled leaf rake? No suggestions, having done all of that work? No. How many of you remember to make at least one of your invention definitions something beyond a leaf rake? Several people did? That's good. They're not all limited to leaf rakes? That's good. That's good. Well, we're going to talk initially about claim breadth, or term breadth, or whatever. We have a little chart up here. And we had the handout. We're going to have a little exercise that we'll do in a little bit, which is, I think, really quite fun because I don't have to take it myself, and you folks do. But one of the things that I learned when I first started teaching the class 12 years ago is that everybody looks at terms differently. People come from different backgrounds. When they see a word, it means one thing to them, and it means something else to somebody else. Moreover, it was very difficult for people to know whether one term was broader than another in the context of a patent claim or an invention definition. That had never dawned on me that people would have that difficulty, but as a result, in the second year that I taught, I developed an exercise to help demonstrate the differences between two different terms, to let people think about whether the one term is broader than the other. And I had thought initially that it would be pretty obvious, but it's not. It's something that once you understand it, it's obvious, like most other things, but at first it's somewhat confusing. If we take an object that reflects yellow light and white object, the question is, are those nested or are they non-nested, and are they overlappable? And how do you determine that? Well, you try to think of examples that fall within the scope of one that won't fall within the scope of the other. Anybody have any idea as to these, which one would be the broader term?
I guess the white object.
The white object would be broader? Anybody have a different view? So we're in agreement. One different view. You're not sure. Well, that proves the importance of the exercise. Yes?
Doesn't the object that reflects yellow light also include a white object? Because a white object also reflects yellow light?
It does. That's correct.
But then yellow objects reflect yellow light, so it's not all included, right? So
You have a comment?
I think they're non-nested.
yeah.
You think they're non-nested? Okay. If they're non-nested, then there should be an example of each one that doesn't meet the other one. Now, it's really easy to think if you have a yellow object, that's going to be an object that reflects yellow light. And a yellow object is not a white object. So yellow object is an example here that would not be encompassed within that one. Can you think of an object here that wouldn't be encompassed within this one? Can you think of a white object that's not going to reflect yellow light? Hearing no answers. I think it's sort of, by definition, a white object reflects all colors, so it is inherently going to reflect yellow light. Okay, so what we know is that one of these is nested within the other. Yes?
If a white object is an object that emits the light, could that be non-nested?
Ooh, that's clever.
For example, like a star.
Yeah, a star, I guess it should have said an object that reflects white light, shouldn't it? To be really more clear. When you think of a white object, you normally think of this, but that's a very good point. As I said, each person looks at words differently. And literally, you could look at a white object as an object that doesn't reflect light at all, that just emits white light. And the yellow light that strikes it would be absorbed, in theory, with that hypothetical. But let's assume that this is a conventional white object rather than a star in the universe. And even that star in the universe, my guess is if the yellow light went in, it might come back out. Maybe it wouldn't be reflected, though, would it? Because it might not have a surface that would reflect it. So that's a really good point. Okay, a white non-emissive object, how about that? To try to get away from the sources of white light. Or a white reflecting object. That's even better. All right, so we'll redefine our terms here. And then one is nested within the other. But to the extent you read white object as encompassing just an emissive and non-reflective source, then they would be non-nested. Okay, so which is broader than which? 1 or 2? One is broader than 2. Okay, so that's the answer, huh? Okay.
Doesn't the white light reflects the yellow light and other lights too? So does that make it broader?
But, okay, an object that reflects yellow light can be a white object, but a white object has to be an object that reflects yellow light.
Yeah, you can look at it. What object is going to reflect blue light? This one has to reflect blue light. This may or may not. So this is a broader one because it will encompass things that will reflect blue light or not. That's why this is tricky. That's why we have a special exercise on this. You need to think about this. And when you try to write patent claims and you have to think about patent claims, you need to be able to sort these things out in order to get the broadest possible coverage. Okay, Golden Girl and Silver Twins. Oh, wait a minute. We didn't finish the first one. We also have a question as to whether or not they're overlappable. Can you have an object that both definitions would read on?
Yes.
Yes. That's easy. White object. Okay. Golden Girl and Silver Twins. Non-nested, that's right. Okay. With common element or without common element. And when I refer to common element, this is a semantics thing. This is not what's going on in your head, is that they're both females that are both of those. It doesn't say girl or golden. It says silver, girl. So this is without a common element, non-nested. And are they overlappable?
No.
Any other votes? I think I can have a group that has both the Golden Girl and the Silver Twins all together. So they are overlappable. Overlappable simply means that I can have one conglomeration that each definition will read on.
So when you say like the All-American Marching Band would be a group that has both of those included in it, is that what you mean?
Well, you could say that too, right? Absolutely. That's a good example. Or I could just have the three girls together holding hands. Okay? My definitions will read on that group of 3 people. And if I don't recite connections between them, it's overlappable anyway because they exist. If I don't have a relationship defined among the 2 Silver Twins and the Golden Girl. Yeah.
What's the common element?
Can you explain the non-nested without common element again?
Well, there's the common element. Common element refers to the actual words in the definition. And there's no twins in that. There's nothing silver in that. It's just a literal comparison among them.
What's an example of something that's not overlappable? Because I mean, you gave the example that you could have the Silver Twins and the Golden Girl like together.
Mm-hmm.
Couldn't you like take any comparison and put them together and then say they're overlappable as a group?
You cannot if the definition carries within it an exclusionary term. An entirely blue object is not overlappable with an entirely red object. You can't have an object that is both entirely blue and entirely red.
But couldn't you take the blue object and the red object and do the same thing you did with the Golden Girl and Silver Twins?
Well, then what you have together meets neither of the definitions. Because that combination is neither entirely blue nor entirely red.
But a group of Golden Girl and Silver Twins, neither like it wouldn't be entirely Golden Girl and it wouldn't be entirely Silver Twins.
But it doesn't say only in front of those. If it said only the Silver Twins and only the Golden Girl, then that would be non-overlappable.
I mean, but it wouldn't say only red and only blue. I don't understand.
An object whose only color is red. The moment that you try to put it with something else, it fails that definition, because that object is then combined with something else and it's not only red. It's when you have an exclusionary component of the definition that says it can't be combined with anything else by its innate nature.
So saying it's a Golden Girl, that's not exclusionary? Like that includes other things?
It doesn't. The Golden Girl is the Golden Girl, but it doesn't say the Golden Girl and nothing else.
Well, I mean, wouldn't you said a red object that wouldn't just exclude
A red object is fine if you say an entirely red object. That's different. If the object is red, that's fine. But if it's an entirely red object, that means it can't be connected with something else.
So if you said only the Golden Girl?
If you said only the Golden Girl, you can't have only the Golden Girl and have other girls with her.
Right.
So then, if you define this combination together, then it wouldn't read and would be not overlappable. There are very, very few things that are not overlappable. And it has to have a very exclusionary aspect of the term in order to have that. And one of the things that we're observing with this discussion is that each person looks at these words differently. As I think we had a very good input on the white object, because I think the one student's input was very, very, very good, but different than other students. Other students were thinking of a piece of chalk as a white object, weren't thinking of it as a source of light. And anytime you're making these comparisons, you have to keep in mind that each person's going to look at it a little differently. And we're going to do an exercise in just a few minutes where you get to practice on this. And what people do, because they realize that there's some ambiguities in these things, is that they put a little footnote beside it. Because they say, well, I don't know whether he's going to mean it this way or that way. And you put a footnote and you explain your footnote, and that's fine. And as long as the explanation helps clarify why you've chosen the one you have, that's fine. The other thing that you'll find is when I grade these, there are several different answers that I count right. Because there are different ways people can look at these and come up with answers that are legitimate. And one of the things when you get into interpreting patents that's really sort of fascinating, when the patent claims are written by the patent attorney and then they're examined by the patent examiner, they have one vision as to what those terms mean. And then when the patent gets to court, the patent gets to be decided by a jury, and the judge goes through what's called a Markman hearing, and the judge redefines that claim according to what he really thinks it means, using different words than the patent attorney picked, different words than the examiner was thinking of. And then the jury looks at this redefined patent claim, and it depends upon what the goal of the invention is as to how those words get redefined by the judge. And this is really disconcerting, particularly to engineering students that like things to be black and white and very clear. But in fact, things do get modified in the process, sometimes for good and sometimes not. And you have very, very smart judges. So you'd think they can figure this out really well. This is what they do for a living. They've gone to law school, they've gotten good grades, they've been appointed federal judges. The problem is, even though they're very, very bright, their decision goes up to a court of appeals, which has other very, very bright people who look at what the judge did and they say, half the time, the judge figured it out wrong. This is a very difficult thing. There's a 50% reversal rate, roughly, in the decisions that the judges make deciding what these terms mean in patents. They go up on appeal. The Court of Appeal says, no, it didn't mean that at all. It meant this other thing. So I'm trying to give you an explanation of why these concepts of what these terms mean, which is really the broader, which is the more narrow, they really do play out in real life in in ways that you might not initially think about. So what I'm going to do is hand out my exercise and let you spend some time responding. This is not open notes, so if you have one last second or two to look at it, you're welcome to. So you put away the handout, and we'll leave that up on the board to the extent it helps you. In the past, I've not done it quite this way. In the past, some people have thought that they could have more than one X in a line. You can't. You can't have both nested and non-nested. It's either with or without a common element. It's either one of those three. So you should have only one X and then a yes or a no on the right column. So here we go. Enjoy. This will be fun. Okay. Now, there's probably a more efficient way to get these distributed, but this will work. I have to start picking them up from the front so that everybody gets the same net time. Almost never do I force people to do things rapidly. So if it takes you time, the goal is to get it right. And this does not count much of your grade, so if you get it wrong, that's okay too. Are you done?
Yeah.
I started with you, so, okay. Hopefully it looks a lot like that one. You're not quite done, are you? Okay. No? No. I can tell you that in 12 years, actually 10 years since I've done this, nobody has gotten them all right. Even though I'm generous in giving multiple different answers right. So, and this doesn't count very much of your grade, so not to worry. You're eager to get the answers, are you? Here you go. Are you done? Okay, go this way. You're done?
Sure.
Okay. There you go. Think you're done? All right, well, continue on. How are we doing? You about there? Okay. There you go. Okay. So
No.
you're not done. You're still working on it, huh? Let me get you. There you go. Okay. It's unlike anything you've had in any other course, I know. Okay. Okay. There you go. Getting close. Okay. There you go. Yeah. How we doing? You there?
Yeah.
All right. Trade. Okay.
But they're not.
One more.
Just do it.
What?
I don't think I put my hand.
Okay, well, by the process of elimination.
Yeah.
I don't know.
Maybe I did. I should put it right here. Oh, I did. Okay, cool. Just making sure.
Okay.
Got the intimidation factor down there, but there you go.
Yeah, that's. I think that's enough time. Okay, great. Well, are there any questions about any of these answers? They all make sense now that you see the answer key? That's-
Common element is?
common element means the same word is recited in both, essentially.
Wouldn't those supposed to have a common element? Because I just went off pure semantics, object. And I put that.
The one before that has red.
Well, red isn't an object.
That's the one.
Well, no, those are completely different concepts there. The next to the last one is the most challenging. Yeah, the next to the last one, let's take a look at that next to the last one and do the comparison. Okay, we've got an object that reflects red light. That's pretty easy. And an object that absorbs all visible light that is not red. Okay. An object that reflects red light. An example is this. An example also would be a red object. That's why it looks red, because it reflects red light and nothing else. So this defines the property with respect to how it deals with red light. It says nothing about the object dealing with any other color of light. It says nothing about how this object reflects blue light or absorbs blue light. You have no clue. The only definition that we have is a term that says the object has to reflect red light. Now, if we look at the second definition, an object that absorbs all visible light that is not red. So this tells us something about a whole lot of colors of light other than red. We know absolutely nothing about what this does with red light. And so the two are completely different. They could read on the same object, and they could each would have an example that would this would read on a black object. This would not read on a black object.
Wait, how can that read on a black object? If it doesn't absorb red light?
Doesn't say that it doesn't absorb red light. It only says it absorbs all visible light that's not red. Doesn't say what it does to red light. This is how patent attorneys look at things. They take it literally for what it says. And so this can read on a black object, this cannot. This can read on a white object, this cannot. Therefore, they're non-nested. Now, whether it has a common element or not, one could debate. The common element might be an object, or you could say it doesn't have a common element because it's really just either answer would be fine. Overlappable? Sure.
Elaborate why his answer would be fine with the non-nested. Why? I think it's obvious they have a common element. Why?
They have a common element in the term object. They're both objects. That's a fine explanation, and I would count that right. But sometimes I'm looking for more than just a generic thing. Everything is matter, I suppose. So either would be counted right, whether it would have a common element or not.
Object that can both reflect red and absorb all visible light that isn't red, so they're not exclusive, right?
They're not exclusive. No, they can both read on the identical object. A red object would be suitable for both of those to read on. That's a separate question, which isn't really presented up here. But a red object would absorb all colors other than red and would reflect red. So that's the most tricky of all of the answers. Some of the others are interesting as well, but yes, question.
Can you explain overlappable? Because I was trying to understand the second one, sodium-free diet and diet including table salt. So you just said you just needed to find a way to group them together. So I said a recipe book.
A recipe book, I don't know that. A recipe book is a sodium-free diet. Is it?
You just need to find a way to group them, be able to group them together and classify them more like a diet book or.
I suppose if it had said a sodium-free recipe and a recipe including table salt, then that would be overlappable.
Or like a nutritionist will be able to tell you.
Yeah, but you can certainly argue that. It's yeah.
I had a question. The one with the rake with 10 times, rake with 20 times.
Okay, that's fundamental. That's core.
They're identical in scope.
What?
I thought those were both identical in scope.
No, if I have a rake with 15 tines, One of them will read on it and the other will not. The rake with 20 tines will not read on a rake with 15 tines. Yeah, and that goes to the core of how it is to understand patent claims. You really have to understand that whenever it says a rake with 10 tines, that means a rake with at least 10 tines. And you put at least in front of things when you're interpreting patent claims. Okay, it's been fun.